All right, ladies and gentlemen, today's lesson is on winds. We've got a couple of concepts to breeze through, pun intended. Um, so let's go ahead and get started. Before we get started, you need to set up some stuff in your notebook. There's four concepts we're going to be learning about today: wind, sea breeze, land breeze, and jet stream. Um, Take a minute to make sure that you've got all four of these words in these boxes on a new page in your science notebook. So press pause, um, and then unpause when you have everything set up and ready to go. Awesome. So let's start with the first thing. What is wind? So by definition, wind is the movement of air from high pressure to low pressure. You could almost think of this as wind wanting to fill in the space um, as it's going through the air. So whenever we have a high pressure system, it's going to move its wind into a low pressure system. This is caused by the uneven heating of the Earth's surface. If you guys remember back to light and matter, we had our t-shirt experiment where we had different colors of t-shirt under the sun. Different substances absorb heat at different rates, and that can cause different things with wind. Um, as far as a picture goes, we'll talk more about diagrams for how that happens with local winds, but some nice symbol to go with it. And since we've been looking at wind speed, some things that can affect this are natural landforms like mountains, lakes, forests. Uh, the entire surface of the planet Earth has an impact on wind. Also, differences in air pressure. If you have a more extreme difference from that high to low, you could have a much bigger uh, or a higher wind speed. And then lastly, altitude. The higher or lower you go through Earth's atmosphere can have an impact on your wind speed and power. So go ahead and pause and get this stuff in, and then unpause to move forward. Okay, you don't need to take any notes right here, but this is what we're going to be talking about with local winds. Local winds refer to two things: sea breezes and land breezes, and this is all about what part of the local wind is warmer or cooler based on the time of day. Sea breezes are also called lake breezes, depending on where you are, but we'll call them sea breezes because that's what happens. By definition, this is when your wind starts over a body of water. So, in other words, the body of water is our high pressure system, and then it's going to blow over onto land where it is less dense and lower pressure, and it's going to keep cycling through. So the air heats up over land, then sinks over the water where it moves back onto land. So if you guys remember our heat transfer, we've got warmer air rising and cooler air from the ocean filling in that space going all the way in the cycle. We've got convection. Um, all you need for the picture is just this general idea of having some water, land, and then getting the drawings of the convection circle moving in the right way for these. And then the time of day, this happens in the morning and the afternoon when the land has been heated up by the sun. So again, this would be like during the day, that land is like the black t-shirt or the different colored t-shirts that can absorb more heat. Um, and then that's going to heat up the air above it, causing it to rise up. So go ahead and pause and press continue when you're ready to move on. All right. The opposite of a sea breeze is, no surprise, a land breeze. And the definition of this is when it starts over on land. So, in other words, now the land has become cooler than the water. So, the air is going to cycle through. It's going to go over the water where the water is going to be warmer than the air around it. So, it'll rise up and then sink back down and keep going in this cycle. So, time of day it happens is at night. If you feel like this is helpful, writing in how it happens is a good idea. So, again, warm air over the water. Um, it's not necessarily warm, but it is warmer, is going to rise up. This air is going to move over, then sink over the land because it's cooled off over the land. and then it's going to create wind and breeze back over the land, or not land, sea, and then it's going to rise back up, go back to the land where the wind will then move over there. So the wind is starting, that's where we're feeling the breeze until it cycles back. So go ahead and pause and add that in there. Okay, there is one more thing with global winds, but this is stuff that happens over the planet. A sea breeze or lake breeze is going to happen on like your local lake or your local shore. While these are major events, it's usually something that's just held within something that we can observe at the time. Now let's talk about the winds that are global. These affect every single place on the planet or encompass a large piece of the planet. And the one that we need to know in our neck of the woods is called the jet stream. So the jet stream is a band of fast moving wind that is high up in the atmosphere. And we mean fast. This is some really cruising wind and it's constantly moving through. This is like a river of fast moving air through the atmosphere. So, what the jet stream does for us as far as effects on weather, if you look at this picture here, it divides cold air and warm air, kind of like a giant barrier. Um, as this barrier moves farther north or south, so let's say the jet stream were to move south towards Mexico, all this cold air from the north would move over the United States and lower the temperature. Let's say that the jet stream got bumped up closer to Canada. Um, all this warm air from the Gulf of Mexico, maybe a little bit here from the Pacific Ocean, would move in, causing it to be a little bit warmer than usual. And the jet stream does bounce back and forth quite a bit. It's just part of how it works. Um, what it also does is that because it's like a river, if a storm gets caught on this jet stream, it's going to be carried all the way across the United States. That's why most of our weather starts um, here in the Pacific Ocean and then moves west, or sorry, not west, east. My mistake. Starts west and moves east. And this is across the entire planet in the northern hemisphere. This whole thing is wrapped around. Um, yeah. So again, carrier systems can raise or lower air temperatures. So the jet stream is a pretty big deal that tells us a lot about the weather we're working with. All right, that's the notes I've got for today.